Okay, next let's look at chapter 3 where we have 4 questions starting with question 7. Right. So question 7 in your revision kit. The present value of a 6-year receivable annuity begins in 2 years' time. At 5% per annum compound is 83,025. What is the annual amount of the annuity? Now, we know, first of all, they are asking for the annuity amount. To find the annuity amount, they have given actually the present value. See, the present value. So, this indicates that we should use the present value of annuity formula, which is annual cash flow multiplied by annuity factor at the particular interest rate given, which is 5% per year. Fine. So they want us to know the annual cash flow, and they've given from which year the annuity starts. It starts in 2 years' time. 2 years' time means it starts in the second year. Okay. So if you draw a year map, so we'll take 0, 1, 2 and go up to how many years long? 6-year receivable. So let's go up to 9 years. Right? So they said they are starting in 2 years time means in the second year only they are starting. So if they say in 2 years time, that means it's equal to in the second year. Okay. If that's the case, now they are going to pay it for 6 years. That means 6 times. Okay. Which is from year 2 onwards, 6 times will be up to year 8. Sorry, year 7. Fine. So that there are 6 payments now. Fine. So you all must be aware that annuity factor are calculated from year 1. Additional. They are actually the additions from year 1. But so if we multiply annuity factor for year 7 straight away to our annual cash flow, we will actually get the present value of year 0, not of year 2. But what we want is basically the present value of this particular set, the 6-year period's cash flow. Of course, it is in today's terms, in year 0. But it's not as the answer we get if you multiply by the annuity factor just straight away up to from year 7. In that case, what we do is we take the annuity factor at this interest rate for the year before the first annuity payment, which is year 1. The year before the first annuity payment is year 2. The year before that is year 1. So take that year's annuity factor. Then take the last year's annuity factor, which is year 7, because the last year whenever last annuity payment is made. So take annuity factor at year 1. So this is the present value table. Let's go to the annuity factor table. Okay, they are going as cumulative present values. Alright, so the annuity factor table, year 1's annuity factor is at 5%, 0952. Write it down. And year 7's one is 5786. Then the total is 4.8, sorry, the difference is 4.834, which is the annuity factor at 5% for not year but a period of 6 years. Okay, because it is for this gap's present value, annuity factor, which could be used to find the present value. Therefore, now multiply it, so now put it to the equation again. present value of annuity is equal to annual cash flow into annuity factor. We know the present value they gave in the question. It's 83,025. That is equal to the annual cash flow we don't know, but the annuity factor we know, which is 4.834. Therefore, A will be equal to 83,025 divided by 4.834, which is 17,175. So that will be answer B. Okay. Alright. So let's go to the second question. Second question is question number 11. How much needs to be invested now at 8% per annum to provide an annuity of 10,000 rupees per annum for 15 years? Okay, starting in 5 years time. Okay, so they are asking the present value of this annuity payments, because they are asking if you are to invest this annuity amount right now, what should that amount be? To understand that, let's first again, as done previously, map out the years. So 0, 1, 2, let's go for, so it's a 15. Okay. Right. So if the annuity of 10,000 rupees starts in the 5th year. 5th year is this year. So 10,000 starts here. But it starts in the 5th year, right? It's correct. But it goes for 15 years. If it goes for 15 years, then you have to go for how long? 15-year gap. So this is a 11-year gap currently if we go up to year 15. We therefore must make it a 15-year gap. We must go 4 more years forward. Okay. Then if you apply the annuity and take the total, see, it's 15 times or 15 payments. Okay. So our last year of payment is year 19. And our first year of payment will be year 5. As we did previously, we must therefore get the difference in the annuity factor and only multiply it to get the present value. Right? So here the percentage is 8% per year, and the year should be the year before the first annuity payment year. The first annuity payment year is year 5. So therefore we should select year 4. And the last annuity payment year should be put here, which is year 19. Now that will give the gap of annuity factor for a period of 15 years. So year 4, what is the annuity factor for 8%? 3312. And this is also 8%. Year 19, it's 9.604. The difference is 6292. Now we need the present value of annuity. That's equal to annual cash flow of 10,000 multiplied by the annuity factor. Actually, this is 8% for 15-year period. Period is a very important word because it make sure that it's not the 15th year but the 15-year period. 6292, your answer will be 62,920. Okay, so they've asked to the nearest rupee. The nearest rupee is actually 0, so I mean it's 0 here, so nothing else to round off, so it's fine. You can give it as 62,920. Alright, next question, question 24. Mr. N wishes to invest a lump sum at 9% interest per annum. How much should he invest now in order to have 40,000 rupees at the end of the next 3 years? So this is a lump sum payment related present value question. Okay. So in lump sum payment present values, we usually write the equation or formula as present value multiplied by the equals lump sum payment, which is a one-time payment, not a regular payment. It is paid only at once. Into the actually, since it is paid only one time, we must consider the discount factor and not the annuity factor. Discount factor, what's the formula? 1 over 1 plus r to the power n. Okay. Right. So the lump sum payment is what we need to know. Well, they've not given it, but they've actually given the lump sum payments value at the end of the next 3 years. That means this is basically the future value of the lump sum payment. So the normal formula of present value, if you take your book, it's basically future value multiplied by discount factor. In this case, the future value is of the lump sum payment and they are asking the present value of that particular lump sum payment. Because if we are to invest money now, how much we should invest? And that also we need to invest only one time. So how much? Okay. Present value is we don't know. So present value equals future value we know, that is 40,000 rupees. Multiply by which discount factor? Actually, in this case, it should be the discount factor at the interest rate given, 9% interest per annum. For how many years? They mentioned they are going to have 40,000 at the end of 3 years. So, you need to write find for 3 years. So, 9% for 3 years is, if you go to your present value table, 9% for the third year, 0.772. Okay, multiply 40,000 by 0.772. The answer will be 30,880. Okay. But what exactly they have given in the as answers is the formula to get this final answer of 30,000. Fine. We know we multiplied it by the discount factor. So how did we get this 0.772? It is basically by applying this formula, which is 1 divided by 1 plus 9% to the power how many years? 3 years. And that we basically multiply by 40,000. That will give an answer of, if you multiply fraction into a whole number, you know that if there's a number just remaining, that means below it there is only 1. Okay. So 40,000 gets multiplied by the numerator, which is 40,000, and the denominator gets multiplied with the denominator, which is again 1.09 to the power 3 multiplied by 1 is same, 1.09 to the power 3. Therefore, what will be the answer? Not the A, no. It is answer D. Okay. So answer is D. Fine. Next, let's go to the last question, question 26. Okay. A company requires a sinking fund of 800,000 rupees in 4 years' time. So the future value is 800,000 rupees at the end of 4 years. They can invest X rupees at the start of each of the 4 years at 4%. Okay, so if we have years 0, 1, 2, I'm going to put it as year 2 beginning, year 2 end, year 3 beginning and year 3 end, year 4 beginning since they said up to year 4 and year 4 end. And I'm going to find, okay, so now what they say, X is invested at the start of each of the 4 years. The first payment is made now. That means now means what? Year 0. Okay. Remember now if they say it means it is year 0. Which is the beginning of the first 4 years. Value of X. Okay. So they want what is the amount that we are going to invest every beginning of the year. So basically we will be investing X in year 0 today and year 2 beginning, year 3 is beginning and year 4 is beginning. When you see the word payments made at the start of each year, you must remember the term advance annuity. Okay? You know there is a formula to calculate advance annuity which is under the geometric expression for advance. What is it? S equals AR multiplied by R to the power N minus 1. Entire thing divided by R minus 1. This is the formula we use to find the future value of advance payments. But now we know what is the future value, so we should find what is this A, the annuity we may have to make. So where AR is actually 1 plus R, where R is equal to the interest rate. Okay. So the future value is basically S determines is representing the future value. Okay. So therefore, we know the future value is 800,000 in 4 years time and the first payment is starting now. So we no need to do any adjustment like here where we took the difference of annuity factors or discount factors. Not required. Why? Because the payment starts in the beginning of the year, like of the first year at year 0. Fine. Therefore, 800,000 will be equal to annuity we don't know, but it gets multiplied by 1 plus we know the percentage interest which is 4% per annum multiplied by so that gets multiplied by this 1.04 to the power 3 minus 1. And this will be equal to 1.04 minus 1. Okay. So if you solve for A, sorry, this is to the power 4. Sorry, because it's under the 4th year. It's up to the fourth year, so it should be to the power 4. Be 800,000 divided by 4.416, which will give 181,146. Basically, nearly this value. Yeah. So the answer will be so they are asking it to the nearest rupees 1000. So thousands means what? You all know the thousandth place here is this particular 1000. So to the nearest 1000 means first step to in rounding offs we learn that first we identify the place value of the number. The place value of the number here is 1000, which is 1 here. So because they require rounding off to the nearest 1000. So 1 is that. So for then to round off the near place this 1000th place value, look at the digit before that. It is still 1. This digit must be, if it is less than 5, then we do nothing to the place value digit. But if this particular one is more than 5, then we add 1 to this particular one, the place value. So in this case nothing. So since they are asking to the nearest 1000, what we do? We write 1, 8. It's still 1 because the one next to it is less than 5. And you put the comma and the rest of it, they asked up to nearest 1000. So the rest of it you should put 0. After the place value of the digit, whatever comes after that becomes 0. So your final answer will be 181,000. Alright. So with that we finish chapter 3 revision and let's move on to chapter 4. Chapter 4, let's look at question 1 in the revision kit. A loan of 60,000 rupees is to be repaid by 15 year-end equal in payments. If the interest is charged at 9%, what is the value of the annual payment? Okay. So they are basically asking the annuity we make because we are making equal payments. That's why I said it's an annuity. If you are making different payments each year, then it is not an annuity. But they have said that they are making equal year-end payments. Fine. So straight away, it's straightforward. What you should do is first write up the present value of annuity formula, which is annual cash flow multiplied by the annuity factor. The annual cash flow is what we are supposed to find, isn't it? Yes. And 60,000 is the present value of the annuity because I have told you all during lectures that the annuities in a loan or lease, the annuities are, the present value of them are always the initial borrowed amount or the loan amount because of the time value of money theory. So accordingly, we can substitute the loan value of 60,000 here to the formula equals the annual cash flow is what we need to find. But the annuity factor we know it is 9% for 15 years. Since they didn't give anything that starts with year 4 or year 3, we can assume it straight away starts from year 1 because they make year-end payments. And since they make year-end payments, we have no issue of whether it's paid in advance or in arrears because it is paid within the same year. So if you go to the annuity factor table for 9% for 15 years, 9% 15 years, you have 8.061. Now annual cash flow therefore will be equal to 60,000 divided by 8.061. That's equal to 7,443.25 exactly. Okay, so now they are asking rounded to nearest rupees 10. So to the nearest 10. Now what is the 10th place digit here if we look at this? So it's 7443.25. So the 10th digit is basically the number 4 over here, which is bolded. Okay, the number 4, which is this. So now, if this is the place value, the rule is we should look at the number next to it and see whether it is greater than 5 or less than 5. It is currently less than 5 at 3. Then do nothing to the place value digit. But if it is more than 5, then you have to add 1 to the place value digit. So it's less than 5. So what will be your answer? Therefore, it will be 744. And we need only up to the nearest 10th, which is the 10th place value. So the rest will be 0. And the 0.000. So that 0 doesn't matter. So the answer will be 7,440, which is answer D. Okay. Next question. Question 2. Over a period of 12 months, the present value of the payments made on a credit card is 21,000 rupees at a discount rate of 3% per annum. What is the equivalent, that means equal, same, constant, monthly amount, not the annual amount. It's paid on a monthly basis. Now here also they are referring to the find the annuity. Actually annuity in monthly terms. So the regular payment. So basically it's the monthly regular payment. So it's basically an annuity. Okay, but not annually. It's going on monthly basis. So the number of months total is 12 months. Over 12 months they found the present value of the payment is 21,000. So present value of 12-month payment is 21,000. The interest is 3% per year or month. It is per month. But we will first now draw up the formula, write up the formula which is present value of annuity equal annual cash flow. Or maybe we'll say the regular cash flow because it's not annual here multiplied by the annuity factor. If you look at your annuity factor table, they clearly say that this is periods and they don't say whether this is a month or a year. So we should think that this can take any form of period. Even a day it can reflect. Alright. So what you need to do is, since it's 3% per month, it doesn't matter. You can straight away look up to this table because they don't, So, basically, therefore, you could write regular cash flow 21,000 multiplied by the annuity factor 3% in the 12th period. So, 12 months and 3% per month. Okay, both must reflect the same days. In that case, the annuity factor is 9.95. 21,000 equals that. Sorry. So the answer will be this is not 21,000, sorry. So basically this is the regular cash flow multiplied by this is equal to 21,000. So 21,000 divided by 9.954, 2,110, which is, they've asked to the nearest rupee. So 2110, the rupee value is 0, so no worries. You can simply go, it will be answer B. Next, let's go to question 5. Question 5. A leasing agreement is for 5 years. 20,000 must be paid at the beginning of the first year. Okay, that means it should be paid in year 0. Payment. And then it is to be followed by 4 equal payments at the beginning of years 2, 3, 4 and 5. So years 1, 2, 3, 4, 5 at the beginning of these years. So basically second year beginning, third year beginning, fourth year beginning and the fifth year beginning, you will be paying something. They did not mention what the amount is, but they are equal. Okay, that's why I wrote X for all the years. If not, it will be X, Y, Z and so forth. But since it's an equal payment, so it can be represented by a single letter. Then, they say it's at a discount rate of 8%. The present value of the 4 equal payments is 52,992. Okay, present value is of this set is 52,992. Okay, so how to get the, so if we have to just calculate, okay, before that, we'll see they are asking the total amount to be paid during the lease period. First, let's understand what they've given to us. So let's see how they got this 52,992 and then work backwards. So basically they multiplied the payment by the discount factor. In this case year 0 it's 1. So 20,000 into 1 is 20,000. Whereas the discount factor at what's the percentage? 8%. For year 2 0.857. Year 3 0.794. Year 4 0.735. And year 5 0.681. So our total will be this x, right? So it will be 0.857x, 0.794x and so forth. So this total is only equal to 52,992. So the total of this is basically, okay, I cannot take it. So what I'll therefore tell you is, if the total of these is equal to 52,992, basically what does it mean? It means the annuity factor at year 5 for 8% multiplied by the annual cash flow X is only equal to 52,992. Actually, it is for year 4 because beginning of year 2 is the end of year 1. Okay. So what we need to actually do is the discount rates used basically must be 0.926, which is actually year 1. We could name it end of year 1 end, and this is year 2's end. Okay, and this is year 3's end, and this is year 4's end. because the present value table shows the year-end figures. Alright. So actually as per the question it goes in second year beginning, but that's basically equal to the first year's end. So we should use the discount factor 0.926, the first year's one, and then 0.857, second year's one. Third year 0.794, and fourth year it must be 0.735. Actually there's a, yeah, so this should be actually your discount factors, right? So then annuity factor for year 4 at 8% is basically the total of this. The total is, as you could see, it's 3312, and if you check the annuity factor table, it is still at 8%. It is fourth one, 3312. Same thing. You see, because it's coming from year 1. So 3.312 multiplied by the annual cash flow, which we don't know, equals 52,992. First find the annual cash flow. 52,992 divided by 3.312. Annual cash flow therefore will be equal to 16,000. So they are asking for the total payment. That means we have been paying 16,000 every year. Okay. So what will be our total payment? 84,000. Okay. This is what they are asking. Just the cash out, the actual cash going out is 84,000. But the value is different in present value terms. Okay. So they've asked, yeah. Fine. Next, question number 13. A loan of 30,000 rupees for 15 years at 7% has been repaid at the rate of 3,290 at the end of each year. Okay. If the loan is to be closed immediately after the 8th annual payment, find the amount outstanding at the 8th year. So they have a 15-year loan. Let's draw the picture. 15-year loan, and the loan amount they borrowed is initially 30,000. That is the present value of the loan, and they have been repaying it with 3,290 every year. Okay, 1,290 for 15 years they have been paid. No, they haven't paid, they are to be paid. But they are going to close the loan by the 8th, after the 8th annual payment. After the, what's the 8th annual payment? This. So from this will be the last repayment. Okay. This is the last repayment. 8th. Alright. So what they are asking is, find the amount outstanding. The amount outstanding. Outstanding as of here. So the present value, so this is basically annuities, right? So the present value of an annuity is equal to the annuity multiplied by the annuity factor. You know, I mentioned earlier, present value of the annuity is always equal to the initial loan amount. So, in that terms, we could say that 30,000 will be equal to the present value of the annuity. Now, this is the actual annuity figures. But what is the present value of the annuity? 3,290 multiplied by the annuity factor for, now we need for 8 years. Okay. They are saying you adjust it to 8 years. Even though it is for 15 years, you should adjust it to 8 years. And say, and because the up to 8 years only, it is 30,000 will be there. Right? Not actually 8 years, actually with the, I'll come to that. So you should first then take, since we need the 8th year cutoff, we will take the annuity factor at the particular interest rate 7% for year 8. But you know that 30,000 is for the 15 years annuity, not only up to the 8th year annuity. Then what should be the balance outstanding? That also you must add. Balance outstanding, we don't know, it should be something, but that multiply by the discount factor at 8th year. Because balance outstanding balance is here at the 8th year. Because when we do our annuity loan table, we will get the annuity actually the total outstanding over here. But we can't simply, take the minus of all this and say that's 3,680 is outstanding. No, it's not like that. Because it works, you all know how we calculate the values for a schedule, loan amortization schedule. So what you need to do is, you need to remember that the present value of annuity only equals to the initial loan borrowed amount. So we equaled it. But this annuity of 15 has been divided into two parts. First part is up to 8 years, which is reflected by this formula. And the balance part is the balance outstanding we could take than taking for the balance, 7-year period. Here you will have to then take the annuity factor differences and then find out. Then that something will be outstanding as of the year 8. Then that outstanding's present value then surely will be equal to the initial loan amount. Since it's outstanding as at year 8, we use the discount factor because it's not an addition of several years, it's as at. So we use the discount factor without using the annuity factor. Hence, if you substitute the values, 30,000 equals 3,290 multiplied by the annuity factor at 7% for year 8 is, factor at 7% for year 8 is, annuity factor for 7% for year 8 is 5.971 plus balance outstanding we don't know, but that multiplied by discount factor at the 8th year is how much? $0.623. 3,290 multiplied by 5.971 minus 30,000 divided by 6.623. The outstanding amount is, in present value terms, it's 16,600. So the discount factor is actually at year 8 is 0.582, apologies, 582, and if you resolve this, it will be 3290 multiplied by 5971 minus 30,000 divide by 0.582, 17,792.8. So the question they asked to the nearest rupee, well, so here it's not nearest, the rupee value is 2 and the value before it is actually 8. 8 is greater than 5, so you should add 1 to 2. So basically it will therefore be 17,793. That will be the answer for question 13. So there could be decimal differences, but in this case, since it's 0.8, because we've taken sometimes they must have applied the formula, it depends. But if it's nearly this, then you could select the same answer. Answer D.